We're finishing up the conic section, the hyperbola. What I'm hoping you will learn in this screencast is how to complete the square if necessary and find the center, the vertices, and the foci and graph a hyperbola. Just to remind you, the hyperbola is the fourth conic section we're covering. Here's the example of a hyperbola. Remember, it has two parts to it. In the last screencast, we learned about a hyperbola that has its center at the origin. And if you remember, here are the definitions of the vertices and the foci. And here are the equations. This is the equation when the transverse axis is horizontal. That means the axis that goes through the vertices and through the foci. That's going to be a horizontal line. And these are the equations of the asymptotes. And then this is the equation for a hyperbola whose transverse axis is vertical, like this y-axis here. And here are the equations for the asymptotes. Now what we're going to do in today's lesson is we're going to move that center away from the origin. So we're going to say the center is at HK. Notice most of this is the same. The only thing that's different is that we're adding the h and the k. This is still x squared over a squared and y squared over b squared, as is this is y squared over a squared and x squared over b squared. Let me remind you of a couple more things. Unlike the ellipse, a doesn't have to be the bigger number, right? And so what determines whether or not our hyperbola is facing up or down or left or right is which variable is written first. If x is written first, it opens left and right. And if y is written first, it opens up and down. So what we're going to do is we're going to look at this example. So we want to find the center, the vertices, the foci, and the asymptotes and draw the graph. So first of all, does this open left and right or up and down? Since x is written first, it opens left and right. So we're going to be using this set of definitions because the transverse axis is the horizontal axis. So let's identify, oh, don't forget, this is what it's going to look like. That's what we were saying. It opens left and right. Now let's identify those key variables a, b, and c. Well, a squared we know is 9 and b squared is 1. Which means a is 3 and b is 1. Now let's find c. Well, remember, c squared is equal to a squared plus b squared. Well, a squared is 9 and b squared is 1. So c squared is equal to 10, which means c is equal to the square root of 10. Now let's fill in all the blanks. The center, the vertices, the foci, and the asymptotes. Well, the center is at 2, -5. And the next thing we need to do is find the vertices. Well, to find the vertices, you're going to start at the center. In our example, it's 2, -5. And then you're going to go to the left a units and to the right a units. In this example, a is 3. So we're going to subtract 3 from 2, and we're going to add 3 to 2. So the vertices are at -1, -5, and at 5, -5. Now to find the foci, we're going to move left and right. So we're going to start at the center and go to the left c units and go to the right c units. So c is the square root of 10. So the foci is at 2 minus square root of 10, comma -5, and 2 plus the square root of 10, -5. Lastly, we have to find the asymptotes. So remember the equation for the asymptotes. So the equation is it's going to be y in general, it's y equals b over a times x and y equals -b over a times x. So in this example, we have y plus 5, which is taking this expression that's in parentheses, is equal to, now this is where we need b over a. So b is 1 and a is 3. So we have negative 1/3 times x minus 2. Remember, x minus 2 was in parentheses. And then the other equation is y plus 5 equals positive 1/3 times x minus 2. And when you work that out, you get that the asymptotes are negative 1/3 x minus 13/3 and y equals 1/3 x minus 17/3. I want to show you how to graph this on the next screen. So just like I showed you in the previous screencast, I start by graphing the center, the vertices, and the foci. So this center is at 2, -5. The foci are at 2 minus, or actually I did the vertices next. The vertices, remember, at -1, -5, that's graphed here, and at 5, -5, that's graphed here. Now the foci are at 2 minus the square root of 10 and 2 plus the square root of 10. The square root of 10 is a little more than 3. So we're going to move a little more than 3 units from C. So if I'm moving to the right, it's going to go 1, 2, 3, and then a little bit more. Not quite at 6 yet, and not quite at -3. Okay, so those are the center, the vertices, and the foci. Remember, that's the transverse axis. So I know that my hyperbolas are going to be opening left and right. Remember, we saw that on the previous screen too. Okay, next thing I'm going to do is draw that box. So remember, for the box, I've used A, right? That tells me how far to go to the vertices. And now I'm going to use B. And B, if you remember, it's not here, but B, remember, is the square root of 1. So I'm going to move up 1 and down 1 and draw a rectangle. I did that here. And then once I draw my rectangle, I'm going to go right through the corners and the center. So these 2 corners on the diagonal and through the center, that's one of the asymptotes. And then I drew the other asymptote here. And then I know those are my guidelines that helps me draw my hyperbola. It looks like this. Those asymptotes, remember, are y equals -1/3 x minus 13/3 and y equals 1/3 x minus 17/3. So that's what our graph looks like. Let's look at another example. So find the center, the vertices, the foci, and the asymptotes of the hyperbola, then graph it. So for this example, we're going to have to complete the square twice. So what I did first is to get on my way to having it look like I want for a hyperbola. I added 63 to both sides of the equation. And now I'm going to start to complete the square. Well, to complete the square, I have to have lead coefficients that are +1. So I factored out a 9 from the y terms. I factored out a -4 from the x terms. Pay close attention to the signs here. See, when I divide these 2 terms by 9, I have y squared minus 2y. And over here, when I divide by a -4, I get x squared and this should say -6. Let me fix that. Okay, so this says -6 because I divided 24 by -4. So that's why I have a -6. Now I have to figure out what to add here and what to add here. Well, half of 2 is 1 and 1 squared is +1. So I'm going to add a 1 in this parenthesis. Half of 6 is 3 and 3 squared is 9. So that's what I'll add inside this parenthesis. So I added 1 and I added 9. But pay close attention to what got added over here on the right. If I'm adding 1 inside here, it's really like I added 9 because 9 times 1 is 9. So that's where this 9 came from. And if I add 9 inside this parenthesis, it's really like I subtracted 36. Negative 4 times positive 9 is a negative 36. So that's what I add, I'll put that in quotes, to the right-hand side, a negative 36. Cleaning that up, I get 9 times y minus 1 squared minus 4 times x minus 3 squared is equal to 36. 63 plus 9 is 72. 72 minus 36 is 36. I'm going to have to divide by 36 now. So I'll divide every term by 36. So 9 divided by 36 is 4. That's why there's a 4 in the denominator. And 4 divided by 36 is 9. That's why there's a 9 in the denominator. And 36 divided by 36 is 1. Okay, so now I have my equation in the proper form. From here, I can figure out what a and b are. A squared is 4, and b squared is 9. That means a is 2 and b is 3. Now I'll plug that in my c squared equals a squared plus b squared equation to determine what c is. So c is the square root of 13. I went quickly through that, but does that all make sense? I hope it does. All right, now let's talk about the graph and finding the center, the vertices, and the foci, and the asymptotes. So we have our equation. Because y is written first, we know the transverse axis is going to be vertical, right? So we know the transverse axis is vertical. What will be the center? The center is going to be positive 3, positive 1. We need the x-coordinate and the y-coordinate. The vertices, remember from the center, the vertices are going to go up A and down A. And A, remember, is 2. So it's 1 minus 2 and 1 plus 2. So we got vertices at 3, negative 1 and 3, 3. The foci go up and down C. C, if you'll remember, is the square root of 13. So the foci are going to be at 3 and then 1 plus the square root of 13 and 1 minus the square root of 13. You see those here. Lastly, we need those asymptotes. The equation of the asymptote is y minus 1 is equal to a over b. A is 2, b is 3. We have plus and minus that, and it's times x minus 3. Those all come from the parentheses here, right? And remember, a is under y, and b is under x. Always remember, slope is rise over run. Now, if I clean these equations up, I get these two equations. The asymptotes are negative 2/3 x plus 3 and 2/3 x minus 1. Okay, now let's look at the graph. So here's all the information we gathered on the previous screen. Nothing new there. That's what we covered in the previous screen. I just want to help you with the graph. Just like I always do, I start with graphing the center, the vertices, and the foci. What I do next is draw that rectangle. So I'm going to draw a rectangle through the vertices. And then to figure out how wide my rectangle is, that comes from B, and B is 3. So from the center, I'm going to go to the left 3, and I'm going to go to the right 3. And then I'll draw my rectangle and draw a nice asymptote through the center and the corners of my box, the corners of my rectangle. The equations for those asymptotes are written here. And then I'm going to draw my hyperbola. So my hyperbola is going to have its vertex at V at the vertices, and we're going to draw those two U shapes. And that's it. All right, that covers everything in section 7.3. Email me as always with your questions.